Okay, today is day 2 of the quadratic formula, 6.4 day 2. And let's just start with a warm-up here. Evaluate. Give an exact answer and an approximate answer rounded to two decimal places. So here's the quadratic equation, the quadratic formula in action. And if we are going to give an exact answer, then we are going to leave the square root as is, and when we're given an approximate answer, we're going to calculate the answer. So for example, here we have x equal plus or minus the square root of, and if we're going to evaluate here, we have negative 5 squared is 25, and then we have minus 4 times negative 3 times 7 is negative 21. You can really do this all in one calculation. The reason why I'm splitting it up is I want to bring your attention to the fact that this is where a common error occurs. Students forget to multiply negative 4 times negative 21, so you need to be careful of that. So I split it up here for that purpose, divided by negative 6. And that will then we'll have x equal plus or minus the square root of 25 minus 84, plus 84, falling into my own trap. Negative 4 times negative 21 is positive 84, and then we're going to divide that all by negative 6. I forgot that there, 5 plus or minus. I forgot that there as well. It's 5 plus or minus. Okay, so what is 5 plus or minus the square root of 25 plus 84? We're going to do one more step here. X equal, well, 5 plus 109, square root of 109, divided by negative 6, or minus, right? 5 plus or minus the square root of 109 over negative 6. X can equal 5 plus the square root of 109 over negative 6, or 5 subtract the square root of 109 over 109, over negative 6. So those are our exact answers. The approximate answers would be plugging that into my calculator. So let's try this. 5 plus the square root of 109 divided by negative 6 would equal negative 2 point, let's round it to two decimal places, negative 2.57. So we can put that. So x equal negative 2.57, or we go back here and see if that'll work. And we'll make that subtract. 5 subtract square root of 109 divided by negative 6, we get decimal 906 or decimal 91. So, or 0.91. Those are the approximate answers. All right. Filling in the blanks. A linear equation has at most one root. A quadratic equation has at most two roots, because a quadratic equation, as you noticed last day, can have 0, 1, or 2 roots. When a quadratic equation cannot be factored, one must use the quadratic formula to find the roots. So let's put that into action by working here to find the roots. I'm going to use this method here because it's a little bit easier to draw smaller, so bear with that, please. So we have 2x squared plus 9x equal negative 6. The first step is we really want ax squared plus bx plus c equals 0. That's really what we want. So we want to put it in that format. The best way to do that is to take this negative 6 and, of course, bring it over or add it to both sides. That's going to help us out here. So let's try that. And when we do so, we'll get 2x squared plus 9x plus 6 equals 0. Okay? And by doing so, now we have our a value, our b value, and our c value. So a is equal to 2, b is equal to 9, and c is equal to 6. Now that we're armed with that, we can employ the quadratic formula. So we have x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and we'll sub in what we know. X equal, our b value is 9, so in this case it's negative 9, plus or minus the square root of 9 squared minus 4 times a, which is 2, times c, which is 6, all over 2a, which is 2a is 2. So we're just subbing in what we know. To evaluate, we just keep going at it. 9 squared is 81, minus 4 times 2 is 8, times 6 is 48, all over 2 times 2, which is 4. And then we get x equal negative 9 plus or minus the square root of, that is, I believe, 33, all over 4. At this stage, if we're leaving, let's double check, our question is asking us to give an answer, an approximate, and an exact answer. So if we're looking for an exact answer, our exact will be x equal negative 9 plus the square root of 33 divided by 4, or x equal negative 9 minus the square root of 33 divided by 4. And the approximate will be what we calculate in the calculator. So negative 9 plus the square root of 33 divided by 4, negative 0.81. We get negative 0.81, or let's try and get rid of that, make it a subtraction symbol, negative 3.69. Negative 3.69. So those are approximate answers. They're not exactly true because we rounded, right? All right, let's take a look at the next question. If we're going to employ the strategy here, the quadratic formula here, we once again have to put this into ax squared plus bx plus c, ax squared plus bx plus c equals 0 format. We're going to keep the 4x squared as is, 4x squared. We're going to bring the 12x over, so it's plus 12x. And then, of course, bring the 9 over, minus 9 equals 0. Now we have our a, b, and c value. A equal 4, b equal 12, c equal positive 9. And I want you to please write out a, b, and c like this because it makes life easier. Let's take a quick look at that. So x equal negative 12 plus or minus the square root of b squared, which is 12 squared, minus 4 times 9, all divided by 2 times 4, which is in this case, of course, is 8. And then we have x equal negative 12 plus or minus the square root of 144 minus, we end up with 9 times 4, which is 36, 4 times, and we actually get 144 again, all over 8. What's interesting about that is we get x equal negative 12 plus or minus the square root of 0 divided by 8. Well, whether you add 0 or subtract 0, the square root of, whether you add the square root of 0 or subtract it, you still end up with nothing. So really there's only one root. It's negative 12 over 8, and that's going to equal, I don't want to get in the way of that, so I'll put it here. That's going to equal negative 3 over 2, or negative 1.5. Interesting. So here, I just want to double check. I had negative 12 plus or minus the square root. Okay, perfect. And we brought the 12 over. Just double checking my work. Minus 9, good. So we end up with, again, plus or minus 0. If you add 0 or take away 0, square root of 0, you're left with the same answer. Okay. And we'll look at the next one. The next question is similar, but we've got to also once again put it into, let me get this over here. We have to still put this into ax squared standard form and let the y equal 0. So we want the y to equal 0 here. So really we want 0 equal x squared minus 4x plus 7. Okay. And in doing so, we have an a value of 1, a b value of -4 and a c value, which is 7. In this case, we plug it in the quadratic formula, x equal negative 4, or negative b, plus or minus the square root of b squared, which is in this case -4 squared, minus 4 times a times c, all over 2 times 1, which is really going to be 2. And let's continue evaluating. -1 times -4 is +4, plus or minus the square root of 4 squared, which is 16, and then minus 28 over 2. And we have x equal 4 plus or minus, this in the case will be -12 over 2. Now, if you look at -12, technically, that's not a real number, because if you have a negative square root, there's no number that can multiply by itself and still remain negative under the square root symbol. So for example, even if you have -5 squared is +25. The square root of 25, the square root of 20, you can have a square root of 25, and the answer could be -5 or +5, because we know 5 squared is also 25, but we can't have a -25 and square root it, because there is no number that will multiply by itself and also give you that negative number. So that's what I'm trying to explain to you here. All right, in this case, we say we have no real roots. That's just, as you remember, an equation that looks something like this. For example, you have maybe a parabola that is above the x-axis, opening upward, and will never touch the x-axis, so that there are no real roots. Whereas for this question here in the middle, we end up with -1.5. You can have just one root, for example, like that. And of course, with the other equation, you have 2 roots, which you're used to by now. All right, that's it for this lesson, and we'll see you in class. Thanks.